So for number 1, a 0 is a y-intercept. That's false. A 0 is an x-intercept. Another name for a 0 is a root. That is true. For C, the coordinates of the max are the same as the axis of symmetry. That is false. The maximum value is the y-coordinate of the vertex. You could have also said the coordinate of the x-coordinate of the maximum is the same as the axis of symmetry. That would be fine. If you specified it was the x-coordinate, that would be true. For D, the axis of symmetry always passes through the vertex of a quadratic function. Technically that is true, but I did specify it should be the x-coordinate to remind you. For E, that is false. It's only the domain that's all real numbers. And then F is also false because if a parabola has a minimum value, the range is going to include all of the possible y values above it. And I just drew that little picture as a reminder, right? So if you have that, it's everything that is above it. Okay, 2A, we went over this a few times now together. You are missing a C term, so you got to factor out your GCF. Okay, for B, they have to multiply to x squared, add to negative 16. So you have to show your work here. Okay, you have to show the factoring, and then each one equals 0. And then I'm fine if you go from this step to this step. That's okay. You don't have to show me like the plus 8. I just want to know that you are taking into account the zero product property. Okay, and then for C, so I know for some of you, you're getting a little scared because it's 3x. Well, that's awesome because 3x is a prime number. What's the only thing that multiplies to 3? 3 and 1. So you would just start with 3x and x, and then the only things that are going to multiply to 4 are 1 and 4 or 2 and 2. So you only have to try 1 and 4, 4 and 1, 2 and 2. In order to check, you check using FOIL. So if I were to FOIL this, 3x plus 1 times x plus 4, I check the middle numbers. This is 1x, 4 times 3 is 12x. That makes 13, so I know that I have it factored correctly. From there, you can set each one equal to 0. Sorry, I knew this marker was kind of light. And then 3x would equal negative 1. I showed that I divided each side by 3. That's where you get the negative 1/3. Okay, and then you have x plus 4 equals 0. X equals negative 4. All right, let's look at A. So for A, it says you have to complete the square. As long as your A value is 1, you are good to go. So you do half of the B value and square it, which is 36. You get 48. You have to simplify your radical. You can simplify it however you want, but the biggest perfect square is 16. So you should have plus or minus 4 root 3. Your last step is to bring over the negative 6. Okay, for this one, I know that some of us were just a little tripped up by the fraction. So if your A value is not 1, this is where you divide each side by your A value. So if you divide both sides by negative 3, okay, that's going to give you negative 2. And then for the next step, it's a fraction, but it's okay, right? If you have a fraction and you have to cut it in half, just multiply it by a half. 4 times 1 is 4. 3 times 2 is 6. When you reduce it, you get 2/3. So you can put your 2/3 squared here. Square the top, square the bottom. 4 over 9. And then remember, this just drops down when you factor. Now I just have to get a common denominator. If it's negative 2, just multiply that by 9. Negative 18 over 9 is negative 2, so it's equivalent. And then from here, take your square root, put your I in front, and then sometimes you get lucky and the bottom is a perfect square. If the bottom wasn't a perfect square, do you guys remember what you do?
Multiply it by itself.
Yeah, you multiply the top and the bottom by that root. Okay? Good. So this one turned out nicer because you did have a perfect square, and then you're going to keep it just like this. If you have the I in front, that would be fine too. Okay? Alright, let's look at the back page. Alright, so this is where you're writing your function in vertex form, and then you have to identify your vertex. I'll show you that. Both of these, your values were not, your A values were not 1. Okay, so if your A value is not 1, you have to factor it out of both. Once you do that, okay, now you can take half of 4 and square it. So 2 squared is 4. Remember, this distributes. 2 times 4 is 8, so if I'm adding 8 here, I have to subtract it here. The functions are the ones where you have to have your f of x equals. And then B was a little bit trickier because you did have a negative to factor out. So if you're dividing by a negative, this will be negative. And then when you distribute, negative 3 times 1 is negative 3. So here you actually have to add 3. Okay, so if you didn't get it correct, please check and see where your mistake was. Did you fill in the blank spaces correctly? Did you forget the negative? Was this one right and this one wrong? Did you factor out the 2's from the x's only? Okay, because you're only going to FOIL it out from the x's. Okay, another thing you can do with those is you can verify whether your vertex is correct using this. You just have to make sure like you show your work from completing your square. But this will be your final form. You have to have your f of x equals. Okay? Alright, and then for 5, you were solving the equation. So for 5a, you should have plus or minus 2I root 6. B is negative 1/2 plus or minus root 2. Now that one was a little bit special because you could simplify it. I talked to several people yesterday about this. Your first step is taking the square root. You take the square root to undo the power of 2. Simplify the square root of 8, and then from there, if you're dividing something by 2, you have to divide both of these by 2. So negative 1 over 2 plus or minus 2 root 2 over 2. Why can I simplify these? Why can I cancel those out? They're both 2, and they're both outside of the radical. Okay, so if it was inside the radical, you can't cancel those 2's out. It has to be the ones on the outside. Okay, and that's why this is your final answer here. All right, and then the complex conjugate, negative 6 plus 5i, that's something that you practiced today. For 7, you should have 4i root 2. Make sure you're breaking down the square root of 32. For number 8, the perfect square is 9. And then you're going to multiply number by number. All right, I'll see some of you after school. Here's the last couple answers if you guys want to write those down. For number 9, because it's a fraction, you're just going to do the square root of the top over the square root of the bottom. So square root of 1 is 1, square root of 9 is 3. The I is going to go behind it. And then, just like we did before, when you're finding the zeros, to save time, you can always complete the square. These answers contain I, so you won't be able to factor, you won't be able to find them on the graph. So you're going to set them equal to 0, move over the C term, and then complete the square. So half of B squared, and then if you don't have any perfect squares in the radical, you will leave it how it is.